Okay, we got an easy one today. Variation functions. So things that vary directly and things with inverse variation. Nice and simple. You read your question, you look for which of the two formulas we want to use, and then we just solve. Nothing to it. All right, so our first one, y varies directly with x. Y is 15, x is -5. Find y when x is 7. So since it says varies directly, we're going to use our y over x equals k. So we have y is 15 over -5 equals k. Right? And then we just divide it, so we get k is -3. So that is our, what's that? That's our constant of proportionality, right? Our rate of change, what it varies by. So then we can take that number, right, put it with any other values we want to find. In this case, we're looking for when x equals 7. So again, we go back to y equals x equals k, only now we don't know what y is. We know x is 7, and we know k is -3. And then we're just solving for y. So we multiply both sides by 7, and we get y would be -21. Okay? So that's one way you can solve direct variation problems. Okay? And this will always work. It's not the simplest way to look at it, but it uses this formula that it tells us here. Okay? If you see a problem like this and it doesn't use y and x, like if this was, if A varies directly as B, then instead of y over x, it would be A over B. That becomes a ratio. So whatever comes first in the question, right? So if it says if, that's your key word, the letter after that will always be the top of your fraction. Okay? All right, let's keep this answer. The other way you can solve direct variation, so the key here, it's got to be direct, is, and like it says, you can just use a proportion for this. So we take our two variables, we have y and x. The order that you put them doesn't matter if you're just making a proportion. We take the first two numbers and make that one ratio, so 15 over -5 equals, and then we take whatever the third number tells us and we put that into our proportion. So this is x is 7, so x is on the bottom. So put that down here. Whatever we're solving for, leave as a variable. And then we can cross multiply and divide. So 15 times 7 is 105. And then we divide that by the number we didn't just multiply. So 105 divided by -5 still gives us -21. Okay? So two different ways you can solve this. You can make a proportion. That's, I mean, I would definitely recommend this way. You don't really have to think all that much. You just make your key, fill in the three numbers that it gives you, solve for the formula. Right? But the original way, using the actual direct variation formula, also works. Okay. Our second case is inverse variation. So direct variation is when you have data and it's going in the same direction. Like if we said test scores compared to hours studied. The more you study, the higher you would expect the grades to be. That's direct variation. Inverse variation is when your data is going in opposite direction. So one thing goes up, the other goes down. So we could say your test scores compared to hours playing Call of Duty, right? The more you play games, the lower your grade goes. Okay. So how we do this, our formula is just x times y equals k, which is really straightforward. So we take the first two numbers in our original ratio, we just multiply. So we say 28 times -2 equals k. So that's going to be k is -56. And then we use that value for k for the value that we're trying to solve for, which, come on, red. So in this case, b is negative 10. So I don't know what a is. So I'm going to say a times negative 10 equals k, which is negative 56. So to get a by itself, we just divide both sides by negative 10, and we get a is positive 5.6. Okay? So nothing fancy here. Basically, all it is, take the original two numbers, multiply them together, and then divide by the remaining number. That's it, every time. Inverse variation. Multiply, then divide. Direct variation, create a proportion, cross multiply and divide. Piece of cake. If you got any questions, let me know. All right, bye.